My name is Olivia Hofmeister, and I will be presenting the physics of X-ray imaging. What is the definition of an X-ray? An X-ray is an electromagnetic wave that is high energy in a very short wavelength. That high energy wavelength can pass through certain materials that light can't go through because it is higher than the regular energy of light. And the history of X-rays is in 1895, Wilhelm Röntgen accidentally discovered X-rays while he was trying to do a different experiment. And this experiment involved cathode rays going through glass, and he just discovered X-rays by accident. Since he didn't know what the rays he discovered were called, he just decided to call them X for unknown. He took his new discovery further and found that the rays could go through human tissue, and this allowed for bones and the other materials in the body to be seen. So he discovered that things like bullets or things that were swallowed could show up on an X-ray. His discovery spread quickly to the doctors in Europe and the United States, and this quickly revolutionized the medical world and greatly improved medicine overall. And a brief physics overview of an X-ray machine is when the X-ray machine is turned on, there's a small voltage that goes through the X-ray tube, which increases the current. This current accelerates the electrons, and the electrons that are now accelerated collide with the tungsten atom, which emits an X-ray photon. The X-ray beam is directed towards the patient, and the X-ray photons have the ability to go through the patient in order to produce an image. And there are different types of X-ray generations. One type is characteristic X-ray generation. This is when an X-ray releases when an outer shell high-energy electron collides with an inner shell electron. This then leaves a hole within the inner orbit. The hole is then filled when an electron from the outer shell comes in and fills this hole, and an electron going from the outer shell down to a closer shell to the nucleus will then lose energy, and this energy is then released as an X-ray photon. And 20% of the X-ray photons released from an X-ray beam that is directed at the patient is this generation type, and you can see a picture of this on the right explaining that as the electron moves down in the orbital levels, the electron then loses energy, and the energy is then released as a photon. Another type of energy that happens is bracking X-ray generation. This is when a fast-moving electron passes by the nucleus. The positive charge of the nucleus causes the electron to slow down because of the magnetic pull. When the electron slows down, it loses energy, and the energy is emitted as an X-ray. And 80% of the X-ray photons released from an X-ray beam are made from this generation type. And you can see that the fast-moving electron loses the energy, and this is how the X-ray photon is released. And producing an X-ray image, while the X-ray photons are going through the patient, the energy of the wavelengths are being absorbed in different amounts. Depending on the photon that it is going through. So basically, the material will then absorb the photon in different amounts. A wavelength detector picks up on X-ray photons once they have passed through the body and produces an image based off of these wavelengths. Bones absorb the most amount of energy, making the wavelengths longer, while skin doesn't absorb as much energy, and so the machine can take how fast the wavelengths are going and produce an image. And you can see a picture on the right. You have the X-ray machine, and then on the other side you have the X-ray detector, and then it produces an image based on the wavelengths. And the amount of radiation is measured in MSV. In the US, people are regularly exposed to 3.7 MSV per year from the radiation of the sun through the UV rays. And this is a good comparison because when you're talking about the dangers of X-rays, you can compare it to a chest X-ray, which is only 0.1 MSV, and a dental X-ray, which is 0.01 MSV. A big jump, though, is CT scans are 4 to 10 MSV, and doctors do not recommend to go over 100 MSV in a lifetime. And the effects of the radiation and the X-rays and the amount of MSV that is absorbed by the person is X-rays generally are low risk because of the amount of radiation a person is exposed to. For reference, in 10 days, you are exposed to 0.1 MSV from the sun, which is equal to 1 chest X-ray. However, CT scans are higher risk because the amount of radiation absorbed is the amount of 1 to 2 years that you would absorb naturally from the sun. And this means that every CT scan that you get, you are aging your cells by an additional 1 to 2 years. And on the right, you can see that there is different amounts of radiation that goes into each X-ray and what the effects of the amount of radiation that you absorb will cause. So dental is really not that bad. Chest X-ray isn't that bad. Mammograms are getting up there, but still not as dangerous. But CT scans are pretty dangerous if you get them a lot because you are rapidly aging your cells. And radiation and cancer. Exposure to radiation leads to an increased risk of cancer and cardiovascular disease. This is because cancer is caused by the mutation of cells, and an increased radiation increases the chance of a mutation in the DNA gene sequence of a cell, which, when a mutation occurs, it will rapidly produce, and this will cause a cancer tumor. And if a person is exposed to 100 MSV, the chances of cancer are increased by 1%. And while for each individual person, this doesn't seem like a huge amount, it is a huge amount per population. For reference, there's 330.6 million people in the US, and if each person was exposed to 100 MSV of radiation from X-rays, 3.31 million additional people in the US would get cancer just because of the radiation they were exposed to from the X-rays. And that is the end of my presentation. Thank you for listening.